Okay, this is just a quick work through of various questions, basically to do with the modelling of exponents and using it for non-linear data. So we've got a function here which is, we've plotted the graph with the logs. So we know that there is a linear relationship between the log of y and the log of x. The line passes through point 0 and 4 and 6 and 0. So what we're asked to work out is find the equation linking log y and log x. Well, that's an equation of a line. Hence, or otherwise, find the equation in the form of px to the q. So this is a polynomial type where p and q are constants to be found. So part A, we've got an equation for a line, y equals mx plus c. And with what we've got here, we've got log, and I'm going to work in log base 10, same as they did, of m log base 10 of x, add on c. So let's get the equation of the line. Well, first part is the c is 4, because that comes from this piece here on the vertical axis. The gradient, m, is the change in y, so it's a 0 minus 4, if I work from the end to the start, over 6 minus 0, which is minus 4 over 6, which is minus 2/3. So the equation we get in terms of logs is minus 2/3 log base 10 of x plus 4. Hence or otherwise express y in the terms of p, x and q. Well, if you can't remember the translations between them, what we can do is we know what form the equation is in, which is p, x, q, and that is something equal to y. Take log base 10 of both sides, which is log p, x, q, q. And these logs start applying the rules. So the first rule is the multiplication rule, which means the two logs add. So log p plus log 10 of x, and the power rule, which says that the q can actually come out and multiply by the log on the outside. So compare the two. Q is my gradient, which is minus 2 over 3, and the intercept is log base 10 of p is equal to my c, which is 4. So we already know what q is, and we know p is equal to 10 to the 4, which is 10,000. So the final form of my equation is y equals 10,000 x to the minus 2/3. So I'm just trying to. So let's just have a look at the graph, just so you get familiar with what these things can mean. So this polynomial type graph, it looks like an exponential decay, but it never intercepts with the y-axis. Doesn't matter how far up I go, this always stays away from the x-axis. This is a vertical asymptote, and it disappears off. So it looks like a normal exponent, but it's not. It's not quite an exponential graph. Okay, so that's the first type of question that we come across. Take a model that's already been given to you in a log form and turn it into a set of equations.